Good. So thank you so much for attending to this training session. The idea of the activity today is just to teach you a little bit how to represent a very simplified hydrogen supply chain and demand technologies for hydrogen in osmosis model. It's basically the same way as we are modeling other kind of technologies. So you will see that essentially it's just about to have all the techno-economic data about the technologies that you need to represent the hydrogen production. And secondly, to know how you are going to use that hydrogen for different purposes. It could be both direct use or maybe for other purposes, like, for example, sports or to represent hydrogen as a feedstock. So let's check what we have for today. Um, First of all, I'm going to share with you in our chat a couple of um, files for working on this. So just give me one moment. Um, Good. Let's check if it works. Okay, suppose that yes. Good. So they are loading. So please go to our chat and download these two files, okay? So the first file is H2 practice, is a zip file. This is basically a model file that you need to upload in the user interface. So it's like a predefined model with some technologies model. So the idea is to use this like a baseline model, okay? And then on top of this model, we will create new technologies to represent hydrogen production and hydrogen demand, okay? That is the first file. And the second file is data case H2, that is an Excel file, and it has the techno-economic data that we need to represent the different technologies and also one hydrogen demand that I want to explain later. So this is the two files that we need to use, okay? So once you have this, please keep it in a side folder and we will use it later, okay? Now I will start with sharing my screen. So just one moment. So this is just a very quick, let's say, introduction. Um, there is one paper that I can share with you that we developed this year about how to represent hydrogen pathways in a country case that was for my home country, Colombia. And here we try to reevaluate the current hydrogen roadmap that we have in Colombia. So the idea was to represent different scenarios considering the targets that are proposed for hydrogen in the future in our country. And in that way, to take into account not just the supply side, but the whole integrated energy system. So the the idea of the paper was to determine how is the different interactions between hydrogen production and the other parts of the whole energy system. And after that, the idea was to formulate some recommendations for a new update of the hydrogen roadmap. So just for using this, because this is the idea of this training is not to explain this, it's just to give you some background. So let's remember that hydrogen is basically the most abundant molecule in the world, and it could be used as an energy vector of an energy carrier, and it could be used not just for feedstock purposes. That is right now the principal use of this material, essentially for what we know as for petroleum refining. That's the first thing, and second for fertilizer production. So as we can see here in the image about the different uses of the hydrogen, you can see here that industrial feedstock is like the most important use of hydrogen right now. However, we have seen in the past years that hydrogen has had an important relevance as an alternative for energy consumption. So, as you can see here, we have different other purposes or uses of hydrogen and also derivatives that we can have from hydrogen. So, in this case, we have, for example, the use as a material, or better, as a substance for heat generation. Also, we can use hydrogen in combination with natural gas for essentially the same use that we have natural gas, that is heat generation or cooking services, etc. Also, hydrogen could be used as a fuel for different transport modes, aviation, roads, maritime, so it's kind of an important um, alternative for transport. And finally, also it could be used, however, we would need to discuss about efficiency in this part, how it could be used for power storage and also for some grid services. So essentially, this is like the big picture about how hydrogen could be important for future energy systems. And from here, it's just to give you an idea that how critical is to put in the table the discussion if hydrogen could be used for energy services in each of your countries, or maybe whatever that you are interested in modeling. So that's essentially all. Here, this is just specific for Colombia. This is about the paper. So here I'm showing you um reference energy system of Colombia, essentially. So you can see here that for most of you, this is kind of the the normal pathway. So we have fossil fuels that maybe in case that you have domestic production, you can do the refining and processing. But also, if you don't have it, you would have importations, right? And in this case, both fossil fuels or also renewable resources could be used for electricity production. That is the first thing that is here. Um, sorry, that is here. And after that, fossil fuels are essentially used also for transport, for the transport sectors and also for industrial sector. And in case that, for example, in Colombia, we have biodiesel and bioethanol production. So we have this kind of blending processes also to supply part of the transport needs. But let's say that this first part, what you can see here in the top part, is like the normal energy system that you have right now. However, we can include an extra new supply chain that is based in hydrogen. So with hydrogen, you can have different methods of production, as we will see later. And you can also use hydrogen not for direct use, but also to produce other derivatives that could be used also, like for example, ammonia or methanol. So after that, we have the part of transport and distribution of hydrogen, and finally, as we saw before, we can use it in different final services. So if we go deep in how to represent the hydrogen pathways, we can include as many things as you want to. It's going to depend on what is the availability of your resources, that's the first thing. And second, what is this kind of technology perspective that you could have in your different countries or regions. So here we have the reference energy system for the hydrogen supply chain in the case of this study in Colombia. So as you can see here, because in Colombia we have reserves of natural gas, domestic reserve of natural gas and coal, it is a possibility to have steam methane reforming. That's the first thing. And there is right now, this is the main method to produce hydrogen in Colombia. But also, based on our important coal reserves, it could be an option to have coal gasification plus CCS, because let's remember that this is a hydrogen roadmap based on low emission hydrogen production. It's not production of hydrogen, like for example, considering the current methods, essentially steam methane reforming, because it is like a combustion, it's based on combustion of natural gas or of natural gas essentially. So we are like producing GHG emissions. So it is not like a clean option, right? And after that, also, obviously, if we are using coal, it would be basically the same. So we are like having a great footprint in the process. So it's important to include CCS. And also, also we have biomass resources. So it could be an optional as well to use agricultural residues essentially for biomass gasification. It could be because biomass, depending on how you are representing it, what are the methods behind, and what kind of crops or residues you are using, it could be the case that the level of emissions is not very high. So we could use biomass gasification only, but just if we want to use it in combination with CCS, it could be all possible to create negative emissions. So it's another interesting option. And finally, we have the ones that are like mostly known by you probably, that are electrolyzers. We have different type of electrolyzers. So here we have um I forget the name of the abbreviation is thing is I forget it. The PEM. Okay, I forget it. I forget it. What is the translation of this? So sorry about that. Probably you already know it. Also we have alkaline electrolyzers and we have solid oxide electrolyzers. So we have like different options for electrolysis that are going to be in two ways, connected in two ways. We can have dedicated projects. So for example, solar power plants dedicated just for supplying electricity for electrolyzers. The same would be for wind and shore power plants. Or also we can connect the electrolyzers to the centralized grid. So there are like two ways. We can have dedicated projects or we can be connected to the grid. That would be like the production section. And after that, we have hydrogen production that essentially would be one of these options for production. But also in this case, we consider the supply of water just to quantify how much water is required for the different levels of hydrogen production. And in this case, this is kind of a consideration of a clues approach, if you are familiar with that. That is climate line energy water systems. So is that possible as well? The same would be for considering maybe land implications of hydrogen production. However, for our training today, we will skip this part, but it's just to let you know that it's possible to represent water, let's say, supply in the process of production, because let's remember that for hydrogen, yeah, for hydrogen using electrolysis, right? For hydrogen using electrolysis, we have electricity plus water, okay? So it's important to take into account what is this kind of water requirements in the process. And also we have this that is out of its scope for this training, but is that we can produce e-fuels or maybe synthetic fuels using hydrogen production. So if we are using hydrogen and we have the carbon dioxide from biomass resources, or using direct air capture, it's possible to reduce the level of emissions because we are accounting for negative emissions. So when we use this kind of CCS plus biomass or DAC for CO2 production in combination with hydrogen, we can have synthetic fuels which could be used as the normal diesel or gasoline or or natural gas, other kind of normal fossil fuels. And the final count in emissions is that we can like more or less cut but by 50% the level of emissions using this because we have negative emissions in the first part of the process. After that, we have the different methods for hydrogen transportation and distribution that essentially is compression plus storage if it's required. Then we can use trailer for transport, or also we can use pipelines. And in the case of exportations, the most, let's say, kind of promising option it could be liquefaction. However, let's say that there are other alternatives that it could be maybe more profitable and also more secure. That, for example, is to transport hydrogen as a derivative or maybe in combination with other um, components in order to be easier the process of transport. But let's once again, this is like outside this training. It's just to give you a very wide perspective of the hydrogen modeling. And finally, we have the different uses as we discussed later before, sorry. So we have blending with natural gas. We can have also direct use for heating production. And after that, in terms of transport, we have what we call the fuel cell electric vehicles, which are fueled by hydrogen. And we have power generation, and also let's say that something that is very maybe very well concerned or very well considered right now is the use of hydrogen for feedstock purposes, like I was telling you before, the use for refining and also for ammonia production that is connected directly with fertilizer production, and finally the use for power generation, just in case that it could be an option, especially for seasonal storage. It could be an option. And many other countries, especially in the south, are interested in checking how feasible is to produce hydrogen for exportations for, let's say, more developed countries which are interested in including hydrogen for their energy systems in the future, especially, for example, Germany and more of the European countries. Okay. So that would be essentially all regarding this background, okay? So after that, we will start with the training in terms of how to model this very small chain. So the first step will be that you need to go to your user interface. It's supposed that for this training, you are already familiar with what the osmosis interface is. So I won't explain anything about the installation of other steps because it's supposed that it's like a prerequisite, like a pre-requirement for this training. So l- um, let's stop here and just please let me know if you have any questions before going straight to what is going to be this exercise, modeling exercise. So any questions? Let me open this because I think I cannot see you anymore. Do you have any questions? Okay, we have to resend the files. Okay, let me try again. Please suppose that they are there. Okay. Oh, yeah. They are loading. Okay, it's done. Please, Romain, are you there? Mm.
Yes, yes, Leonardo, I'm here. I'm here.
Please, could you confirm that you were able to download the files?
Oh, currently I'm using my phone, so I downloaded them, but uh, I have not been able to open on my phone.
Okay. Please, anyone else can confirm that it's possible to download the files?
Hello. Yes, I
Uh,
confirm that.
okay, perfect. Thank you. Good. So what is the first step? We are going to open our baseline model. So you need to click here in the second button. That is the one for um import model. No, sorry, it's the other one. You need to click here in the first button that is restore model, right? So here you need to click then in drop case to restore, and then you can select the H2 practice. I'm not going to do that because the model is already in my files, so it is not necessary. But after doing that, it's supposed that you will have it. Okay, so you just need to click restore model, drop case, then select it. Sorry, this is in Spanish, but here it would be open. And then the model should be with you. So something like this. So here it should appear in the list of your models. Good. So after doing that, suppose that you can select it. Okay, then you can go and configure model. It's suppose that once again, this is more or less something that it should be familiar for you. So here, the idea essentially is just to, let's check the model diagram. If we go to simple, you can see the reference energy system for this baseline model. So here you can analyze that we have different options for electricity production. So we have, for example, solar power plants, onshore power plants, hydropower plants, coal power plants, geothermal power plants, diesel power plants, natural gas power plants. All of them are useful for electricity production, that it would be electricity 001. Then we have transmission and distribution technologies. And then also we have one battery system here for electricity storage in the distribution stage. And after that, we have different electricity demand technologies. Like for example, we have electric cars, we have electric trucks, we have electric stoves, and we have electric boilers, right? So in this model, something that is important to say is that we have demands for the end use sector. So we have four demands. We have one demand for cooking, right, in the residential sector. We have demand for car transport in the transport sector, obviously, and also we that would be for passenger transport. But for freight transport, we have also one additional demand that it would be freight transport demand. And also in the industry sector, we have indirect heating demand, that it would be the one that is satisfied by boilers. So what other options we have for those demands? We have, in the case of indirect heating, we have coal boilers. That is the one here. For the case of freight transport, we have diesel trucks. That is the one here. Then for cooking, we have natural gas stoves. That is the one here. And also for cooking, we have natural gas stoves and we have biomass stoves. That is the one here. And finally, for passenger transport, we have gasoline cars. That is the one here. Okay, so as you can see here, this is like a very simplified energy model, but we are trying to represent, let's say, a whole energy system, but in a very simplified way, just to use this like a baseline model. Okay, so after being completely familiar with we have here, sorry, not appear. Okay, it's here. We are going to start with the creation of our technologies. So please go to the other file that I share with you, that is the data case H2, right? Excel file. Okay. And here in this Excel file, you have 4 tabs. The first tab is one single demand for hydrogen. When you are modeling hydrogen, normally you already have one hydrogen demand that is usually related to feedstock needs, right? So if we want to include that hydrogen demand, because we need to consider that if we are producing hydrogen, hydrogen will be used for energy uses and for non-energy uses. So in order to take into account the whole production of hydrogen, we can create an additional demand to represent those non-energy needs. So this is the one that we are using here. So this is hydrogen for feedstock uses. So we can see that we start in 2021 with 2 petajoules, that is very small. And at the end, we have around 6.3. So this is like an estimation. Once again, this is a dummy case, right? So all of this data is just for teaching purposes, it's not real data. So let's consider that we are increasing in the use of hydrogen. But let's say that for feedstock is not quite high, it's not very representative in the whole system. That is the first thing. So we have one demand. After that, in the second tab, we have the technology of one alkaline electrolyzer. So different from what I show you before, we will represent just one single alternative for hydrogen production. But obviously, that is, you have enough data, you can represent as many technologies as you need. Okay, but in this case, it would be just one electrolyzer. So here we have the techno-economic data. We will use it later. And then we will represent 2 final end-use technologies. So in this case, we have hydrogen truck, because let's remember, or better, let's consider that there are some final energy uses which are more difficult to be electrified. So let's consider that we have a renewable electricity system. So we are like producing electricity with renewable sources. Once we have that, I mean the decarbonized system, the carbonized electricity system, is possible to use that electricity for other purposes because it's already clean, let's say, because obviously that if we consider the whole life cycle, the whole life cycle, we have some emissions behind, but let's assume that it is more or less clean. So if we have green electricity, we can start to electrify final uses. So in that kind of final uses, there are some which are more difficult to be electrified than others. So for example, what is regarding freight transport, it says trucks, because as the energy density of the batteries for that kind of vehicles has to be very high, it's more difficult to be electrified. However, obviously that technology can evolve and we can have that in a more in a cheaper way maybe in the future, but right now, let's say that hydrogen could be an option for freight transport. It's essentially heavy long haul transport. That is the one that we want to represent here. So for this case of freight transport, we can consider hydrogen trucks. And that is the first thing. And the second thing is that also it could be kind of difficult to electrify the heat generation. Once again, because the amount of electricity could be too much for reaching the level of the high levels of temperature. So here, hydrogen boiler, because the process is not basically this, is not the same, it's not the same for sure, but it could be more or less similar to the process of natural gas in terms of kind of combustion. So hydrogen boiler could be an option for the heat generation. So yeah, those would be the two different energy services that we will represent or model here. So here once again you have the economic data, and we will use it for this representation. Okay. So, once again, we will be in our user interface. So the first step is that we need to create hydrogen as a commodity, right? So here, probably you are again very much familiar with this. So we can just go here on your right, we have add commodity. So here we can include HGG as hydrogen. And the unit for this would be petajoules, and then you can update the model. That would be the one, right? Once we have commodity, we can go and create the different technologies. Here, you can go here, and then we will create three technologies, one for the electrolyzer, one for the hydrogen truck, and one for the hydrogen boiler. Okay, so here, let's create UPS ELE, that it would be our ALK electrolyzer, right? Then in terms, this would be the capacity in gigawatts for the electrolyzer. Then the input would be electricity. In this case, once again, we will use electricity 003 because this is connected directly to the grid, okay? So the input fuel would be electricity plus water, but we are not going to represent the water supply here, so keep in mind that there is like a limitation in this exercise, but you can do it anyways if you want to. So here the unique input fuel would be electricity, and then the output fuel would be hydrogen using the electrolyzer. As we are using electricity, there is no CO2 production, so we don't consider here. And then we have, sorry, we have our truck, so it would be then tra fre HDG. So this would be the hydrogen truck. Then, as we are using, this is a transport technology. This would be in terms of transport units. So you need to go down, and as this is freight transport, we will use gigatons kilometer, right? So this is gigatons kilometer in terms of capacity, and also because we want to avoid to use capacity to activity unit parameter, we will use essentially the same unit. So again, it would be gigaton kilometer, okay? And here for this technology, we know that the input fuel would be hydrogen, right? And the output fuel would be the freight transport demand, that in this case is TRAFRE, is this one, TRAFRE. This would be the one, right? And then the other technology that would be here is our hydrogen boiler. So it would be them in It would be indirect heating and then HDG, right? This is our hydrogen boiler. Then here, once again, because we want to avoid the transformation, obviously you can use gigawatts, and you would need to include the capacity to activity unit if you want to, but in this case we'll keep it simple. So petajoule for capacity, petajoule for activity, and the input field would be hydrogen, and the output field would be basically the heating demand, that in this case is this, that is industrial and indirect heat, right? So this is the one. And once again, don't forget that we need to update model, right? So once again, we are using hydrogen. So after combustion of hydrogen, the outputs are essentially water. So we don't have any emission here. Okay, so here we don't have anything. So there is no emissions in this side. Good. That would be the first part about how to create the commodity and then the technology. Until this point, do you have any questions, any doubts about what we are doing? So sorry because I cannot see you. So maybe just if you want to raise your hand or say something, it would be fine. Or maybe if you want to type your question in the chat, it is possible as well. Good. As no one is saying something, I will continue. So after creating the commodity and also the technologies, we can start with adding the, let me close this. We can start adding the different techno-economic data, right? So we'll start with the hydrogen demand. So in this case, we can go and copy, you know that this works more or less similar to how Excel works. So it is just about copy. Then in data entry, you can go and look for the parameter, in this case, accumulated annual demand here. Then we can go down and check hydrogen. We have hydrogen here, so we just need to click in the first cell here, and then we can copy. We have this kind of strange behavior because it goes up once we do that, but if you come back and check below, you will see that all use values are correctly copied, right? So it's fine. Then we can save data. I usually go to configure outdate data, outdate model, but it's not kind of mandatory. But before running, it's recommended to update the model. Good. So here we have added the demand. Let me check that I think we have one question. Uh, the just practice. Okay, David. I explained that before. Heating home in the home in the home page, you need to click here in restore model. Okay, here you click in restore model, drop case, and then you need to select H2 practice. Okay, and then you click in open. Sorry, this is in Spanish, but this is open, right? And after that, the model should be uploaded in your interface. That is the process to upload the model into the interface. Okay, anyways, let's say that for this kind of steps, let's remember that this session is being recorded. So this session will be shared with you on YouTube, so you can maybe pay attention to all the steps. If you have some questions, you can write down and then just let me know. And maybe just for doing the steps probably is easier that maybe you can wait for the video, then go to the video and try to follow the steps maybe in a slower manner, because here is like we don't have too much time. So probably I think, because from my experience it's kind of difficult to follow all the steps. We always need to wait a little bit because some people are quicker than others, or is like it could be a little slow at the end. So maybe my recommendation would be try to pay attention to the steps, and then after having the video you can just follow the steps in a slower manner, right? So try to pay attention and just let me know if you have any questions about what we are doing. Good. So that would be the way. Then after that, we included the demand for hydrogen, right? Now we will start to include the first technology, that is our electrolyzer. So we have these parameters. They are not the unique ones, right? Because you must know that we have other parameters like fixed cost and variable cost, which is not related to fuel but other kind of consumables. But also we have residual capacity, we have capacity factor as well. But in this example, once again, it's just for teaching purposes. So we are using just the, let's say, the critical parameters for this example. Okay. So here we start with the input activity ratio. And to make it, no, let's do this step by step. So let's go with input activity ratio. So you can go here again, data entry. Notice that we are in data entry. We go here, input activity ratio. Okay. Then with input activity ratio, we need to look for our, this is not here. So you can increase the number of rows here down. We have the electrolyzer here. Please take care that we have two modes of operation here in this model, because we are modeling, we have one battery system. But for all the normal technologies, for everything which is not related to storage, we are always working with the first mode of operation, right? So here you have electrolyzer in mode 1 and you have electrolyzer in mode 2. But the mode 1 is the unique one we need to complete. Okay? So in this case, this is just 1.4. It's going to be constant. So here we need to go to electrolyzer, mode of operation 1, click in the first cell, copy. Again, it bring us to the top, but you can download, you can go down and you can see that the values were copied successfully. Okay, so here we have the values for electrolyzer. We can save the data. Now we are here, so I think it's much better to complete this anyway. So we have the hydrogen truck and the hydrogen boiler. So it would be essentially the same. So here we have the truck. So we can copy the values, go here, first mode of operation, copy, save it, it's fine. Go to the hydrogen boiler, input activity ratio, then select the values, copy, go here, hydrogen boiler, first mode of operation, copy the values, right? We have it, save it. Again, I like to update the model as well. Then we can continue with the next one, that is the output activity ratio. That is 1. For everything is 1, right? Notice that here is 1. because this is the normal convention, right? When we are working, it's like output activity ratio is going to be 1 for all the technologies. So here we have output, right? So again, we can show more rows. And here we have the values. It's going to be the same. So I'm going to copy this, that is 1, right? Oh, better, let's complete the same example. It's just like 1, this is the same, so it's 1. Then we have this for the electrolyzer. Once again, mode of operation 1, okay? So here we have this. It's going to be the same for the hydrogen truck. It's going to be the same for the hydrogen boiler, right? Then you can save it, configure model. And after including the input and the output activity ratios, it's like you are creating the links between the technologies. So if you want to check that everything is fine, you can go to view data. Sorry, you can go to model diagram, go to simple. Obviously that you can see it here as well, right? So for example, you see here that we have the electrolyzer right here, but the problem here is that you can see the commodities or the fields. So I think this is much better. The simple view for me maybe could be more insightful, I think. So in this case, basically, we can verify that it was created correctly. So here, notice that we have the electrolyzer, right? We have that we have different consumption of electricity 003, and then the hydrogen is produced and is used by the hydrogen truck and also the hydrogen boiler. Okay, so that would be like a way of proving that you created the links in the correct way. Good, so let's continue with the addition of the different economic data. So in this case, let's go with the next one. So here we have the capital cost, that would be the one. Just give me one moment, please. Just one moment. Good, so let's go with capital cost. So in this case, once again, very similar data entry. We just need to go to capital cost. In this case, let's check. We have the capital cost for electrolyzer, hydrogen trough, hydrogen boiler. So you can use this over here. Then let's go with hydrogen. Sorry, with hydrogen truck. So copy, right? Then go to hydrogen boiler. Sorry, go down. Please take care that you are copying the value from the first cell, okay? Because it could be the case that the values are not copied correctly. So here we verify that everything is fine. Then save data, the model, okay? Then the next parameter in this case is fixed cost. Okay, let's take into account that for the electrolyzer we don't have any fixed costs. So it's just for the hydrogen truck and the hydrogen boiler. So let's go here, fixed cost. Then copy the values. Let's go down. Good. So here we have the hydrogen truck. For the electrolyzer, we don't have any value, so it's just for the truck one, right? Then it would be the same for the boiler. Good. So everything is fine, right? Then save it. Good. Then the next one is capacity to activity unit, but is one for hydrogen boiler and is one for hydrogen truck, so we don't need it. However, for our electrolyzer, we need to include 31.536 because we are moving from gigawatts to petajoules. So in this case, capacity to activity unit is here. So we just need to go to the right. Here is the electrolyzer. Just put the number, right? And we have it 31. Okay. What is this? This is 100 capacity. Okay, I think we have mistake here. Yeah. Anyways, good. So here, just we can save it. Sorry, here, save it. Here I found a mistake because this should be one for the domestic production. Okay, it is not going to affect the results anyways, but let's change it just to make it better. So this is one. So it should not be 100, right? It should be just one, right? So this is one, this is one, this is one. It's just for mining and import technologies. So yeah, we have here. Yeah, okay, so yeah, that would be all. What happened? What is this one? Let's see, we have one more. That one. Okay, here. Okay, good. So yeah. So please, so sorry about that mistake. So it should be one just for the mining and import technology, the capacity to activity unit, okay? For the power technologies and also for the electrolyzer, it should be 31.536, okay? So good. That would be for the capacity to activity unit that is here. And finally, it's just about the operational life. So it would be 25 for electrolyzer, 15 years for hydrogen truck, and 25 again for hydrogen boiler. So here, the operational life, here is 100 is fine for mining. So here we need to put, for this, it would be 25, right? This one is 15, and this one is 25 again. Okay, so then just save it, configure model, and update it. Okay, so that would be the whole process for inputting or entering all the techno-economic data, right? So that would be essentially all. After doing that, it's just about to run the model. So you can go to run, right? In this case, I already have like one H2 practice run, so we can select it, right? And then, sorry, we can select it and then we can update it, then data file, and then run model, right? So it's optimizing right now. And then the process was successful. So we can go to results, and essentially we can check the different variables. In this case, let's check it just production by technology by mode. Let's check the production of hydrogen. So here we can go and filter by our electrolyzer just to check how is that production, how the production is. So notice here that essentially we are moving from 2 petajoules to 6 maybe something else petajoules. You can also change that here in value. So if you want to check more decimals, right, you can click here, okay, and here you can see what is the, sorry, else I think it doesn't work for float 1000. No, it should be float, sorry, it should be float, not 1000, should be float. And then you can see that here we have 6.3. So we are producing from 2 to 6.3. That it would be our fixed stock production, right? So it's just that the model is deciding that to satisfy the demand with the hydrogen truck or the hydrogen boiler is too much expensive. So it's much better to go directly with fossil fuels in this case than using hydrogen technologies. However, this is once again, this is just for teaching, right? But you can just check, for example, if we want to check here, let's say, let's go and check the transport sector. So you can go here, right? Notice that here, as you can see, is like for transport demand, the passenger demand is being satisfied by gasoline cars, and in the case of freight transport, demand is being satisfied by diesel. But it's essentially because we don't have any extra constraints on the model, so hydrogen is too much expensive to compete against diesel or gasoline technologies. Okay, so it's more like that. But in terms of the other demand, that is hydrogen for feedstock, is like basically the electrolyzer is producing the required amount. Okay. So that would be essentially all. Then you can play around with all the variables. You can modify other kind of constraints. You can try to tune a little bit the techno-economic parameters in order to see maybe if hydrogen can penetrate a little in the different uses. But it's going to be like exercise that you can do on your own, depending on what data you have and what is the kind of energy system that you want to model. Okay, that would be all from my side. So, I would like to know if you have any questions, any doubts about we did today. So, I'm going to stop sharing, and I don't know. Do you have any questions, any doubts about this? Okay, data is always difficult, but there are different studies, or let's say that data collection data collection is always one of the first steps when you are modeling. So the data, maybe let's say the data is more like an estimation or a forecasting of what the values could be. For the paper that I show you at the beginning of this session, we have a database for that data. So here I'm sharing a paper, data in brief paper with all the data about hydrogen technologies. So that paper has some values and also has the original sources for gathering data. So probably it could be useful for you. There you can find the different technologies that we represented in the Colombian model. And there you have, I think, a good way to start. Because it's like everything is summarized in one single paper. And then if you want to go deeper, you can just check the original sources and maybe try to check if you maybe can find an additional values. But yeah, that paper would be useful for gathering data. Okay. So considering that we don't have questions, that would be all for this session. Once again, thank you so much for attending this meeting.